Following on from the lesson on the mid-ordinate rule, we're now going to look at another method of numerical integration, Simpsons Rule. This method can be very accurate and is in fact the method that the calculator's approximations of definite integrals is based upon. It's named after Thomas Simpson, a mathematician from Leicestershire, who came up with this rule in the 18th century. As I said before, it offers a very good approximation to definite integrals, often completely accurate. It's based on modelling quadratic equations, quadratic curves to points on the actual curve. I hope you remember this from Core 2, the trapezium rule. And we handle Simpsons Rule in a very similar way. This shows you how it's modelled with this blue curve, our function of x. If we're looking for an area under it, Simpsons Rule uses a quadratic curve modelled to 3 points in a shifting way to the actual curve. You don't need to know this, but I'll actually show you a bit more. I'll put this on the PowerPoint that goes on Moodle, so if you're interested in seeing how Simpsons Rule's derived, you can see how. This is just to give you a bit of an overview of different approximations for integrals, different numerical methods. We've just learned the midpoint mid-ordinate rule. This rectangular rule, we use those mid-ordinates. Trapezium rule we learned in Core 2, and now we're having a look at Simpsons Rule. As you can see, it looks like it's a better approximation, doesn't it? And it does generally provide a very, very good approximation in most cases. This is the formula here, where n is the number of strips. We have to have an even number of strips for Simpsons Rule to work, which means we have an odd number of y ordinates because we use, obviously we have a y value at either end. So we have one more y value than the number of strips. The width of each strip we get by subtracting our limits, the upper limits, and then take away the lower limit, and dividing by the number of strips. And as with all of these numerical approximations, we get greater accuracy by increasing the number of strips.
Simpson, Homer Simpson, il più grande uomo che la storia avrà. Dalla città di Springfield un castagno in pieno prenderà.
Okay, but on my way, I'm gonna be doing this. If you get hit, it's your own fault.
Okay, then I'm gonna start kicking air like this. And if any part of you should feel that air, it's your own fault.
I better go check that out. Now, Homer, don't you eat this pie.
Okay. All right, Pie, I'm just going to do this. And if you get eaten, it's your own fault. Oh! 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 My... Oh, the hell with that.
Okay then, let's work through an example. So here we're going to use Simpsons Rule with 4 strips to estimate this area. and give a final answer to 4 decimal places. So we use the formula. We've got 4 strips, so we'll end up with 5 y ordinates from y0 to y4. Good idea to write out a table of values like we've done with other rules, like the trapezium rule and the mid-ordinate rule. So because we're going between 0 and 1, with 4 strips, we're going to have a width of a quarter, aren't we? So it goes 0, a quarter, a half, 3/4, 1. We find out the y values by putting these x values each in turn into here. And then plug everything into our formula. And this is what we should get. Okay. Have a go yourselves. If you're successful, then you're ready for the lesson. If not, perhaps you need to have a quick look back over the video just to make sure you understand it. And this is what you should have got. So a similar approach, 4 strips, 5 y ordinates, 5 x ordinates, between 1 and 3, so it's going to be a half, isn't it? So we've got 4 strips, so 3 minus 1 over 4 gives us a half. That's our width of each strip. And then we find out the y values, it's 1 over x. And you should have ended up with 1.1000 to 4 decimal places.